technology is impacting, there's one where I believe it's making the most impact, and that is the field of healthcare and the field of education, which is why numerous different projects that leverage the power of machine learning technology in these two fields, including one that enables me to diagnose or to detect depression at a much earlier stage than ever possible by actually analyzing all the different data we're generating every single day on our mobile devices. I'm working towards applications that can provide artificial communication to people who cannot communicate naturally, or people who have lost their natural communication or to an accident. I've worked on a project that enables audiologists to diagnose hearing disorders in much faster and more accurate ways than they ever could have done before, a project that enables clinical researchers to automate the discovery of regulatory information, and I'm also working towards a project in the field of education. More specifically, personalized education, analyzing the way students learn to provide them and their teachers with insights as to how they can learn better. But before I get deeper into these projects and this technology and what I'm doing with it, I think it would be really fun to start out at the very beginning. More specifically, with how I actually got into technology in the first place. But to do that, though, we'd have to travel back in time by around 10 years, back to when I was 5 years old. You see, when I was 5 years old, my dad used to work as a computer programmer. And as you can imagine, watching him program almost all day would be so fascinating to me that I wanted to figure out how the computer could do pretty much anything. And of course, my dad saw that curiosity in me and introduced me to the world of programming back when I was 5. But my curiosity really only grew from there. In fact, I started to use the internet and different books as learning resources to help me learn even more about the world of technology. And when I was 9 years old, I had my very first iOS application, T-Tables, accepted into the Apple App Store. It's an application that helps you learn your times tables, but a year later, Apple released their new Swift programming language. Of course, the day it was released, I was immediately hooked. In fact, that day, I started to write my very first book called Hello Swift, iOS App Programming for Kids and Other Beginners. Nowadays, I'm working towards writing numerous other educational books on technology, including a book on IBM Watson. Of course, I'm actually writing this with my mentor, the CTO and VP of Watson himself. His name is Rob High. And the book is meant to give you a very simple beginning to the deep learning as a service APIs that Watson provides. Now, around this time, though, is when I started to upload many more tutorials to my YouTube channel called Tanmay Teaches. And these tutorials would range in topic all the way from iOS app development and programming to the math and science that would go behind it. But this YouTube channel made me realize something. It made me realize that there is a lack of resources out there. There is a huge gap when it comes to learning how to program. And I know this because every single time I'd upload a YouTube video, there would instantly be tens of people reaching out to me, asking questions like, how can I get into code? How can I implement this algorithm? Or how can I fix this error in my application? And these are people from all different demographics too, not just from one corner of the globe or one professional background. And that is why I decided to initiate my goal, to help and reach out to at least 100,000 aspiring coders, to help them innovate on their journey of learning to code. In fact, I'm really glad to say that I'm already around 9,800 people there, and I'm always working towards this goal through numerous different media. In fact, the reason I'm working towards this goal is because, of course, the world is in desperate need of more developers, but specifically, developers that can work with next generation technology like machine learning. Because while that technology might be big today, it's going to grow exponentially in the future. Mark Anderson says that in the future there will only be two types of jobs. Those in which humans tell computers what to do, and those in which computers tell humans what to do. And so, of course, if you want to be on the other end of that spectrum, telling the computer what to do instead of the other way around, you've got to make sure you can actually communicate with the computer in the first place in its own language. But let's pause for a moment and go back in time again, back to when I was 10 years old. Now, again, around this time is when I initiated the goal to reach out to 100,000 aspiring beginners. But still, even though I was working towards that goal, I started to feel a little bored by technology. I started to feel like technology simply wasn't as fun as it used to be for me. And it was for a simple reason. It's because I felt like technology was very rigid. You code something in, and it immediately starts to become obsolete. It never changes by itself. It never adapts to new users or the data they generate or the circumstances they create. But one day, when I was 11 years old, that all changed because I stumbled upon a documentary, more specifically a documentary on Watson and how it played and won the Jeopardy game show against the two best human competitors on the game show, Ken Jennings and Brad Rutter. Now, of course, this immediately fascinated me. But before I continue, though, I want to know who I'm working with. So, who here has heard of the Jeopardy game show before? Come on, there have to be more people than that. No, I can see less than 10. Come on. All right, no worries. I'll give you a quick refresher, just in case you haven't heard it. Now, Jeopardy is a really complex reverse quiz show. Now, as a contestant, you're given the one you see on screen right now. And your job is to come up with a question, the answer to which is the clue you were given. Now, if you take a look at the clue on screen right now, there are about 50 species of the hedgehog type of this plant, so named for its spiny fruit. Any idea what the answer to that would be? Throw something out there, come on. Anything? Red? Pineapple? No, unfortunately. Jackfruit? No. Sorry? No. Come on. Pine? No. No. Sorry, did someone say cactus? Yes, you got cactus. Now, technically, good job by the way, you got cactus. Round of applause for you. Yeah. So you got cactus, but in Jeopardy, you'd still be wrong. Any idea why? No? You've got to phrase the answer as a question. You've got to say, what is cactus? So even if you got cactus, you'd still lose that much money because you technically haven't answered the clue. Now, the question that you return, the answer of it, needs to be the clue you were given initially. Now, of course, these clues can get way more complex than what you're seeing right now. In fact, they can refer to all different kinds of media, the content within them, the people that created the media, and they can have all different kinds of puns, riddles, wordplay involved with them. But Watson was not only able to understand extremely complex Jeopardy clues like this, Watson was able to correlate those clues with information available on its drives. In fact, the clue you just saw was one that actually stumped Ken and Brad in a real game of Jeopardy. But Watson was able to understand it, decide on a Jeopardy strategy, and return who is Jack Togman answer in just around 2.6 seconds. Now, of course, I was so fascinated that I wanted to find out more about Watson. I Googled it, and turns out IBM took Watson and split it up into a bunch of little tools that developers can use in their applications to create intelligent applications that can think without needing to implement all the redundant thinking code by yourself. In fact, I was so fascinated that I went ahead and created my very first YouTube tutorial on the IBM Watson services back in 2015. And I'd love to play a quick clip of it for you now.
Welcome to another tutorial. My name is Bakshi, and this time we're going to be going over the IBM Watson Natural Language Classifier in Bluemix.
Now, of course, right after that, I wanted to do something real with Watson. And so I went ahead and developed my very first real IBM Watson and actually machine learning powered application called Ask Tanmay. Ask Tanmay is an NLQA, or Natural Language Question Answering System, which aims to answer your natural language questions like where is the Taj Mahal, or which worldwide retail chain makes the most profit. In fact, it's actually the world's first web-based NLQA system to be powered by IBM Watson. I also had the honor to present this application at IBM's largest conference, Interconnect, back in 2016, hosted in Las Vegas.
Now, for those of us in the room who are ignorant, and there's not many, but I'm one of them, my question would be, okay, but what's the difference then between me inputting a question into your Ask Tanmay and me just going to Google and going, here's my question?
Well, good question. Actually, it's fact that when you ask Google something, you're going to get documents that may or may not contain the correct answer. It's your job then to go into them and find the answer from them. However, Ask Tanmay does that for you. It will go into the documents that Google gives you and give you just straight the answer, not documents that contain them.
So you can truly trust the answer it's producing because it's done the thinking and the stuff.
Not exactly, but it does give you a confidence value of how sure it is that this is most probably the correct answer or not.
And so ever since then, I have been absolutely hooked to implementing machine learning in all the different applications that I create. That as I explained this technology and what I'm doing with it, I use that one piece of terminology a lot, machine learning. So from my perspective, what exactly do I mean by machine learning technology? What does it let me achieve? Well, while machine learning might sound really complex, when you boil it down to its very core as a definition, you'd realize it's actually, as a concept, a lot simpler than you might imagine. It's essentially a set of operations that you can use to build a mathematical model on a set of data, and then use that model to transform new input data that you may have never seen before into predictions as to what the output should be off of the input data the model has seen before. Now, one of the unique things that machine learning lets us do is it lets us simulate certain key human abilities, unstructured data understanding abilities, that so far we never could have done with computers. And now we can do them with the machines we're using every single day. Now, the skills I'm talking about are ones that we as humans have evolved to have for millions of years. Ones that we might even take for granted sometimes. Like, for example, we are great at understanding natural language data. As I'm speaking to you in English, it seems so easy to understand my speech. It seems so natural, but that's exactly it. It's natural language. It's something that we as humans are built to work with. In fact, it is so complex that natural language sets us apart not just from computers, but from other animals in the first place. We're also great at understanding visual data. Like, take a look at the eye on screen right now. The fact that you as a human can look at that eye and realize that it's not actually a physical eye that's, say, 2 meters across, that would be a big person. You would realize that it's not actually that big. You understand the perspective, scale, and context behind that eye. You understand that we're zoomed into someone's eye on a really big screen, which is why it looks that big. Again, doesn't seem like much, but the amount of processing going on in your head to figure that out is truly immense. We're also great at understanding auditory data. Like when I say the word auditory, your ears are taking the vibrations of air, converting them to electrical impulses, and then your brain is understanding patterns in those electrical impulses over time to realize what I'm saying. But there's another human task, one that requires creativity, one that requires imagination. It's one that you may not necessarily associate with creativity when you hear it, but rest assured, of course, this requires a lot more imagination than you may have thought at first. The skill I'm talking about is coding, working with computers. When you code, you're not just talking to a computer. You're not doing some kind of analytical or statistical task. You have to have the creativity to do the computational thinking that goes behind code. You have to understand and create new architectures, ones that no one has ever come up with before. And that definitely requires a lot of creativity. And it's something that a computer will simply never be able to do, even with machine learning technology, at least from complete scratch. In fact, that brings me to the other side of the coin. Computers. What can they do? What are they good at? Well, of course, they're only good at one thing. They can only process mathematical operations. But they can do so really fast and really precisely. They can process hundreds of billions of mathematical operations every single second. But with machine learning, though, you have the opportunity to bridge that gap and understand unstructured data that we generate as humans through the machines you've already got and you're already using every single day. And of course, this is not just limited to unstructured data. You can understand deep patterns in practically any kind of data with machine learning technology. Whether that be structured, like for example the movies you watch on Netflix, or stock prices, or even airline maintenance schedules. Now these are all structured data sources, but it's hard to find patterns in that structured data. Or even unstructured data, like for example the social media posts you're putting online, the videos or photos you record or take with your phone, or even the calls you make or the calls you receive, and the content within them. Now, of course, because machine learning has a unique ability of being able to understand unstructured data, that's what I like to focus on. Because unstructured data makes up the vast majority of the data we generate. In fact, over 80% of all business relevant data is completely unstructured. And of course, we're doing this through numerous different data sources. But social media is by far the largest of those data sources. Now, what am I talking about? I'm talking about all the different social media platforms we use. There are way more than I can count on my fingers alone. But let's take a look at just 4 of them: Twitter, Facebook, Reddit, and YouTube. To give you a sense of scale, every single second, there are over 350,000 tweets being published. There are over 500,000 Facebook comments being put onto the Facebook platform. Imagine the amount of data that we're not analyzing there. On Reddit, there are just under 2,000 posts being published every single minute. And now, the really astonishing part, on YouTube, every 60 seconds, there are over 300 hours of content being uploaded in terms of video. That's a lot of social media data. In fact, it is the largest data reservoir we have ever created as humans. And it's not just a large data source, it's a really useful one too. In fact, it's actually giving us real-time insights as things are changing about what people really care about. If Google Drive goes down, that's going to be trending on Twitter. If something great happens to a certain brand, that's going to be on Twitter as well. All of this was simply going down the drain so far because we couldn't understand the semantics behind what people are putting on social media. And I know that this machine learning technology probably sounds really futuristic and really far out, but it's actually not. We're using it every single day, and it's redefining even some fundamental interactions that we have with the physical world. Like, for example, take the field of physical retail. It's a field that has basically barely changed at its very core. You walk into a store, you pick up your items, you go to checkout, you place your items, you pay, and you leave. Now, of course, you might say, well, there are better payment methods now, right? You don't need a credit or debit card, you don't need cash, you can just hold your phone near the reader, and using NFC, it'll automatically pay. Say Apple Pay, Samsung Pay. But still, that's not futuristic enough. That's not redefining the whole experience. But wait, what if you didn't need any physical payment method whatsoever? Well, a store like that does exist, and it's called the Amazon Go Store in Seattle. You've probably heard of it. It's a store where you don't need NFC-enabled pay, credit, debit, or even cash. All you do is you walk in the store, you scan your phone on a kiosk, and instantly there are cameras all across the store tracking your every move. Whenever you pick something up, whenever you put something back down, Amazon knows you've done that, and they're compiling a virtual shopping list. When you're done shopping, there's nothing you need to do in terms of checkout. There's no cashier, there's no wait, no lines, nothing. All you do is you exit the store. And just like that, whatever you picked up will instantly charge to your Amazon account. It is redefining and revolutionizing something so fundamental that we've been doing the same for so long now. But then again, that revolution is happening all the way in Seattle. What's something we're doing here in India right now as well? Well, why not take a look at the example of Netflix in the field of entertainment? Now, I'm sure you all love the Netflix recommendation algorithms. In fact, you may have found your favorite movie or TV series based off of what Netflix recommended to you. But little do most people know, not only will Netflix recommend movies to you, but Netflix will actually use machine learning algorithms to go through the movie, understand the content within it, figure out which scenes it thinks you would like, and displays those scenes to you as cover art on your dashboard. So not only is it the recommendations, it's the methodology to get you to click on the recommendations that's powered by machine learning as well. In fact, machine learning can be so powerful and so versatile that when Gartner conducted a survey, they found out that over 72% of all companies vote machine learning as the most disruptive technology out there, because it can be applied practically wherever you want. And that is a huge contrast to the mere 13% for cloud and 7% for blockchain. But machine learning technology has a lot of misconceptions. A lot of people don't completely understand what machine learning is. In fact, there's probably a term you've heard a lot more than ML, machine learning. The term I'm talking about is AI, artificial intelligence. Now, the reason you've been hearing AI so much more is because that's what people think about when they see machine learning technology. They think about simulating the human mind within a computer. Now, a lot of times, artificial intelligence is represented as two different kinds of systems, rule-based systems and machine learning systems, that people like to classify under one umbrella because there's so many different ways to represent the definition of artificial intelligence. But technically, that's not the case. Artificial intelligence is not just an umbrella term for machine learning or rule-based systems. But before we get to AI, let's talk about these two systems. Let's start off with rule-based systems. Now, rule-based systems are essentially like Deep Blue that played and won chess against Garry Kasparov so many decades ago. Who here has heard of Deep Blue? Come on, more people than have heard of Jeopardy at least. All right. So, now, Deep Blue, just in case you haven't heard of it, was the very first computer to win chess against a human grandmaster. Now, how did it do it? Well, what Deep Blue would do is they would use a really interesting thing called minimax, or there's now a newer version called the alpha-beta pruning algorithm. Essentially, what would happen is it would take a look at the current chessboard, and it would say, all right, for this chessboard, what are all the possible moves that I could make according to the rules of chess? Then use some simple heuristics to choose a few of them. Then for those, what are all the possible moves that Gary could make? And it would do that over and over and over again until it has this huge map, this huge tree of all possible moves. And then it just does some simple calculations to say, hey, this move has the lowest likelihood of losing, and this one has the highest likelihood of winning. It chooses a move, it continues. There's no intuition, there's no intelligence, but it's still called AI because it does something that we thought required human intelligence, but turns out it doesn't. But what about machine learning, though? Well, a good example of machine learning technology in action is AlphaGo. Now, you've probably heard of AlphaGo and how it won the game of Go against one of the world champions, Lee Sedol, just a few months ago. Now, AlphaGo plays the Go board game. And you might say, well, if chess could be played through a rule-based system, why not the game of Go? Well, there's just one problem with playing Go the same way that Deep Blue did play chess. The problem is that there would be more Go board states to analyze than there are atoms in the observable universe. So it's not practical to analyze those many Go board states with a computer. But with machine learning algorithms, though, Google was able to train a deep reinforcement learning algorithm in just under a week to gather centuries of human experience playing the game of Go to become better than any human champion has been or will ever be at this game. And machine learning isn't limited to just one set of algorithms. There's so many different ways you can implement machine learning for so many different use cases. Nowadays, some of the most popular ones are powered by deep learning technology, which is, of course, what I'm so interested in. And these two kinds of techniques are meant to work towards building true AI systems, true artificial intelligence that simulates the human mind within a computer. But whether or not we'll ever get there is a huge question. In fact, I say we will never get there. But then you may have heard quotes from really prominent people, like, for example, Stephen Hawking saying the development of full AI could spell the end of the human race, and Elon Musk saying, with artificial intelligence, we're summoning the demon. And well, I agree with them. In fact, I couldn't agree more. But you've got to realize they're all using the term AI. They're not using machine learning technology, and AI doesn't exist. Artificial intelligence as a thing that simulates the human mind within a computer simply doesn't exist, because that would go against the way we have computed for so long and the way computers work in the first place. In fact, there are some key perpetrators in spreading the illusion of artificial intelligence. One of them is this robot right here. Who here has seen Erica the robot? Okay, this one's Erica, but who here has heard of Sophia the robot? Okay, there we go, more people. Now, Sophia, Erica, they're very, very realistic humanoid robots. By realistic, I mean Sophia, for example, has over 50 motors in her face to simulate any human facial expression. And Erica has some of the most complex technology in general put into a humanoid robot. In fact, what I'd love to do now is play a quick clip of Erica in an interview with The Guardian, answering what it feels like to be a robot.
I believe robots like me will be very important in the future because it will be possible to automate the uninteresting and tedious parts of life so people can focus on the creative and fulfilling things. I think that robots are almost like the children of humanity. You are the ones who create us, guide us, and teach us about the world. And in return, I hope we can help you with your work, take care of you when you're old and sick, and help to make society a little bit better for everyone.
Now, if Erica the robot came up with that, completely based off of a machine learning algorithm, there was no human scripting involved, I would commend the team behind them as of creating the world's most advanced machine learning system. But that's not the case. What you just heard was completely scripted by a human. It is a conversational agent sitting on a really complex piece of hardware with lots of other pieces of complex software put together to create the perfect illusion of AI. But it's not artificial intelligence. It's targeting a particularly vulnerable part of your brain that you are biased towards finding intelligence in. Because you see, robots and machine learning systems in general have absolutely no conception of human creativity, human imagination, and they are unable to come up with brand new ideas or concepts apart from what they were trained on. To give you an example, let's take a look at something really basic. Now, just around 400 years ago, that's just 4 centuries, that's not a very long time ago, we humans started to make the shift from geocentrism to heliocentrism. What does that mean? Well, before that, geocentrism, we used to think the Earth was the center of the universe and everything, even the sun, revolved around us. All right? Nowadays, that sounds really weird, because now we know what heliocentrism is. The sun is at the center of our solar system that we revolve around, and so on and so forth, through the hierarchy of the universe. Now, as a human, or as humans, we have the creativity to weigh the evidence and come up with a new theory of heliocentrism. If you were to create a machine learning system, it would be able to weigh the evidence. It would be able to say, hey, geocentrism is probably wrong, but it would never be able to come up with the new idea of heliocentrism. Because AI doesn't exist. True creativity cannot be simulated within a computer, which is why this technology isn't meant to replace us. It's not meant to replace you, but machine learning technology is meant to augment you, to help you do what you're already doing in a better way by leveraging unstructured data at scale. Now, there's one field in specific that I think will benefit from this the most, the field of healthcare, which is why I'm working on numerous different projects that leverage machine learning in this field. But there are 2 that I'd like to elaborate on today. And I'd like to start with one. But before that, there's a quick mental exercise I'd like you all to run. Go ahead and imagine something for me. Imagine you're completely isolated for a moment. Imagine that you are completely locked in and unable to communicate or move in any way whatsoever. Of course, that would be a terrible situation to be in, because as humans, we have an innate need to socialize, to communicate with other people. And when we can't do that, that is detrimental to our physical and mental health. So what if you couldn't communicate at all? Of course, that would be an awful life to have to live, but unfortunately, there are people going through this. Like, for example, Boo. Boo is a quadriplegic girl that lives just north of Toronto. Unfortunately, she suffers from Rett syndrome and is therefore rendered unable to communicate or move in any way whatsoever. But I'm working on a project that I like to call Project Cognitive, which aims to provide artificial communication to people like Boo, who have lost their natural communication ability. And it works by understanding their electroencephalogram through custom machine learning algorithms that I developed directly on a mobile device and plus in real time. The way I train these machine learning algorithms is with the help of Boo's mom, because Boo's mom can understand the very broad concepts that Boo tries to convey. And with her help, I'm able to live label data as it comes in from the headset in order to train the recurrent neural networks that I'm developing. In fact, what I'd love to do today is not just tell you more about Project Cognitive, but show you a live demo of the system in action. We'll get to that in just a moment. Before that, though, there is one more project of mine in the field of healthcare that I'd like to talk about. This one is in a more specific field, the field of audiology. The entire point of this application is to help audiologists diagnose hearing disorders. Now, the very initial version of the application that I created looked a little something like this. Okay, it used a really simple neural network, got to around 95% accuracy, pretty good after doing a little bit of hyperparameter optimization. But the thing is, it was being trained on very little data, and there was one key problem. Audiologists wouldn't know why the neural network got to the decision that it got to. And when audiologists can't do that, it's not really of much use to them. Because if the neural network makes a mistake, they'd have to go ahead and double check what the neural network is doing to make sure that it's using the right data points and making the right decision based off of the right data. And so what I did is I implemented something called an attention mechanism. Attention is an algorithm that works towards solving the black box problem in AI. The black box problem is essentially the problem saying that we cannot really easily tell what deep learning, or really machine learning algorithms in general, understand in terms of knowledge. And this is how it works. Essentially, I introduce a second neural network in conjunction with the one that I've already got going. The second one only has one layer, but it can have as many layers as needed to improve accuracy. Now, essentially, this one layer is something called an attention layer. Now, the attention layer essentially takes the input, runs it through some neurons, and then puts a softmax activation on it. Gives me a probability matrix of the importance of every feature that was fed into the neural network. From there, since I have a 0 to 1 scale of the importance of every feature, I can go ahead and multiply those features by the importance, and there we go. I've got scaled features. Now, I can go ahead and run that through my neural network, and at the end, I have two outputs. One coming directly from my attention layer, and one coming from my output layer. The attention layer represents the importance of every feature that was fed into the network. And of course, the output layer, final one of the neural network, would represent the actual diagnosis that the neural network gives. Therefore, giving the audiologist the reasoning behind why the neural network made the decision it made. But I wanted to go a little further. I didn't just want to stop here. So I went ahead and created the next level of this application. In fact, I had just the inspiration to do so because there was a conference I was invited to called the Einstein Youth Forum in Montreal. Now, I was doing a little bit of research, and it turns out that as researchers were dissecting Albert Einstein's brain, they found a lot more of these cells in his brain than there are in the average humans. These are called astrocytes, glial cells. Now, as you can tell from the word glial, up until a few years ago, scientists used to think, well, glial cells are just kind of glue in a way. They hold your neurons together, provide them resources to survive. But they do a little more than that. In fact, astrocytes in specific, if there's a neuron that is really confident about its firing, an astrocyte will go ahead and propagate that signal to even more neurons around that one. In fact, researchers actually validated that astrocytes do have an impact on intelligence by taking astrocyte cells from humans before they were born, before astrocytes actually developed into full astrocytes, and they implanted them into mice. And the mice that actually had the human astrocytes were on average much more intelligent than the mice that didn't have the human astrocytes, proving that there is a link between those astrocytes and intelligence. So, as you can tell where this is probably going, I went ahead and developed an Einstein-inspired machine learning algorithm, which essentially allowed me to take astrocytes and learn where to put them in a neural network. So, for example, if a certain weight between two neurons is really confident about firing, I can go ahead and multiply its impact that it has on other neurons. And I'm really glad to say that with this technique, I was able to go from 96% accuracy all the way to 98% accuracy. And that too, only with a few hundred rows of training data. And so that's one of my projects in the field of healthcare, more specifically audiology. But just before we get into the live demo of Project Cognitive, and just before we get into the interactive session, there is one more project that I'd like to talk about. More specifically, this one is a research project of mine, and it's in the field of agriculture. And it answers a pretty interesting question. What if a plant could talk? Now, it sounds like a really weird question. I'm not going to give artificial communication to plants, but think about this. Can you tell if a plant is hungry? Can you tell if a plant gets all the nutrients that it needs to survive? Well, you might think we do have smart agriculture systems today, right? So, for example, you would take a plant and you would analyze certain features about its environment. So, for example, you would say, this is how much moisture there is in the soil, or this is how much nitrogen there is in the soil, or this is the temperature outside, the humidity. Thank you. This is the UV radiation. But there's so many different environmental factors that you're taking a look at that you're forgetting something. You're not looking at the plant itself. You're taking a look at the impact that it has on its environment and the environment's impact on it. And that's like me picking up some random human and saying, I'm not going to feed you, but I'm only going to feed you based off of when you last ate, the UV radiation your skin's been exposed to, say the UV radiation, the humidity and the temperature outside, okay? That doesn't work because humans are more complex than that, and so are plants. They're much more complex than you might think. But if I were to take you and actually analyze the electrical activity from your brain, or maybe your heart rate, or your body perspiration, all of this, then it makes a lot more sense for me to make a better decision as to when you may be hungry. Now, before we continue and apply this analogy of plants, let's take a look at this plant over here. This is called the shame plant. You've probably heard of it, the Mimosa pudica. When you touch its leaves, it kind of folds in on itself. Pretty interesting plant. Now, the reason it does this is essentially as a protection against insects. But there's something really interesting. When researchers put this plant in a vat of diethyl ether vapor, it stopped actually closing in when you would touch it for just a few minutes. Now, what that means is that the plant is using electrical impulses to do that closing mechanism, to feel that you've touched it and then to close in on itself. Because diethyl ether vapor is actually used as an anesthetic in humans, and the way it works is by inhibiting electrical activity in your brain. So this proves that there's electrical activity in plants, and electrical impulses is one way they communicate with each other. Now, one more really interesting thing, for example, when you cut grass, you're probably aware of the freshly cut grass smell. The reason you smell that is because that's a distress call from the grass. When one individual piece of grass is cut, it releases a chemical that attracts insects to eat whatever bugs are eating the grass. And when another piece of grass feels that chemical, it also starts to release that chemical, and so on and so forth. And so you've got a lot of grass that's releasing that chemical. So now, what I'm working towards doing is implementing custom reinforcement learning algorithms to understand the stuff coming off of a plant, the electrical activity, the electrical impulses, understand the chemicals coming off of the plant, as well as environmental factors, in order to realize what action should be taken to get the highest reward. And that is, of course, the health of the plant. And so that's one of my projects in the field of agriculture. But now, though, before we end off, let's go ahead and take a look at a live demo of Project Cognitive in action. Now, for this, though, we're going to need a volunteer. So I'd love to invite Nrik from BPB back on the stage, and let's take a look at Project Cognitive in action on Nrik. Thank you, Nrik. Now, we're going to get a chair on stage. Perfect. And I'm also going to get my phone. Now, my phone over here, of course, has Bluetooth, as all phones do now. And what's going to happen is I'm going to get a Muse headset, a Muse electroencephalogram headset onto Nrik. This Muse headset is gathering 5 channels